Hey everybody, my name is Alex Merced, Head of DevRel at Dremio, and we're going to be talking about today about Apache Iceberg, Agentic AI, and data integration. Moral of the story is just that when you're taking on Agentic AI projects, there are some bottlenecks, particularly when it comes to data access and things like that. And we're going to just talk a little bit about how, one, Apache Iceberg can help solve these problems, and just the nature of these problems as well. Okay? So, yes, let's do that. But first, let me introduce myself. So everyone make sure that you have your phones out because I'm about to feed you a bunch of QR codes. But bottom line is like here is a little bit about me. So if you want my contact information, you can scan that QR code. That'll give you pretty much all my info, and you can give me yours if you want. But I'm the head of DevRel at Dremio. I've been working at Dremio for just about 4 years now, and I've gotten the honor of being able to like spend my days talking about the lakehouse, whether it's Apache Iceberg, Apache Arrow, Apache Polaris, Nessie, all sorts of really, really cool technologies. And in that journey, I've gotten to not only write a few blogs, but got to contribute to several books. So all the books you see on the screen right now, you can download for free. Scan that QR code, it'll give you the links for all 3 books, so you can download those for free. The newest one being the Apache Iceberg Digest Volume 1 that was just released today. That was a collaboration between us at Dremio, Fivetran, PuppyGraph, Confluent, and MinIO. So you get chapters from all of us kind of giving you our perspectives on Iceberg. So do check that out. Okay, don't worry, we'll get to our featured presentation soon enough. Next, I also have another book that I'm currently finishing up, Architecting an Apache Iceberg Lakehouse. This one, I'm raffling off a free copy. So if you want to enter the raffle to get a free copy of this book, scan that QR code. And, oh, let me just put that back up there for a second. Let everyone take their photos. I thought everyone was just taking photos of me, but I guess they're taking photos of the QR codes. Just kidding. These are the jokes. Okay, and then last announcement is, here in San Jose, well, not here in San Jose, well, very nearby in San Jose, we'll be having one of the stops for our annual conference, Subsurface. That will be on November 6th in San Jose. So do register to be at that event. It'll be a cool event. That's dremio.com/subsurface to register for that event. So lots of really cool stuff coming down the pipeline. And with that, let's move on to our featured presentation. Let's first talk about the dream. What is the goal with Agentic AI? Well, the goal is to make it where we can automate things, where we can interact with our tools much easier to make our tooling much more accessible. So initially, the idea was like, it would be great if I could just have someone at the company write a prompt and things happen. I don't just get a text response happening. Like I can say something like, hey, go bring up all the customers and send them an email about our new product release. And then that happens. That would be fantastic. And the way that would work is you'd build an AI agent. And usually you would use frameworks like LangChain. And LangChain would then, you'd hard code all these tools that would interact with maybe, let's say, something like a Dremio to go pull the data for your customers, and then interact with like a SendGrid or a Twilio to then contact those customers. But you would have to hard code all this logic into each individual agentic application. Okay, it would work, but again, each next agent required you to do re-implementing a lot of the same logic over and over and over again. Now, take that to the next step. What if we could reduce the amount of times we have to re-implement the same logic? And this is where MCP came into the picture. So with MCP servers, I could take the logic of interacting, let's say, with Dremio and turn that into a bunch of tools that I can reuse over and over again. Or the logic of interacting with Twilio or SendGrid and put that into an MCP server, so that way every tool or every agent that needs those features, I can just connect to that MCP server. Wonderful. Okay, but do I really want one agent that's connected to like 100 MCP servers to do every possible task I can ask for? No, I'm going to want specialized agents for different batches of tasks. That maybe this agent has access to like these 5 MCP servers. This agent has access to these 5 MCP servers. So this is where you start seeing the agent-to-agent protocol come into play. So now my agents can be aware of each other and request things from each other, giving you that extra level of saying, okay, hey, I asked you to do this, and then the agent I asked to do that can now talk to other agents to go get that task, different parts of that task done. So overall, like this whole sort of ecosystem of frameworks is building up quite a bit. But at the end of the day, all of this is wonderful, but I still need my agent to have access to data. Okay, data because it needs to do things with that data because it needs context, all sorts of variety of reasons, it needs to have access to data. So what are the challenges with Agentic AI when it's trying to get access to that data? Well, I'm going to focus on sort of three particular problems. Okay, there's always other challenges and new challenges that people are solving every day, but we're going to focus on three. One, access to the data. One problem I have is my data is in like 50 different places. I got some data in Postgres, I got some data in Snowflake, I got some data in an S3 bucket somewhere, I got data here, there, and everywhere. So then what happens? Okay, you end up hard coding access to all this data in your AI agent possibly. Okay, and that means you're putting in more credentials into your code, which means more environmental variables, more potential security issues and credentials you have to manage. It gets kind of complicated. It would be nicer if there's sort of a more central way to access the vast majority of my data. And I'll talk a little bit more about how Apache Iceberg and Apache Polaris are tools that can help that part of the problem. Then there's performant access to the data, okay? I mean, one thing is great that if I only have one connection to my data and I can access all my data, but I need to access that data performantly. Like if I write a prompt and it takes like a half hour to do something really basic that I could have done in 10 minutes, then that's not really making me more productive. So having, and especially now, again, a lot of these agents, they may go through several different iterations of those prompts. You really want the query executing not to be the bottleneck along with everything else. So this is where things like Apache Arrow come in, where Apache Arrow allows for really fast in-memory processing, allowing for, basically good performance working with data. And then basically the last bottleneck is semantic understanding of your data. So great, I have very straightforward access to my data, so I have very minimal credentials I'm juggling in my agentic code. Great. My queries are getting executed really quickly, wonderful, but the AI doesn't understand my data. Okay, and has joined the wrong tables on the wrong columns and giving me a chart that doesn't really make any sense. So that's the third bottleneck. What happens when my AI performs quickly but gives me wrong answers? Okay, because it just doesn't understand data. So semantics are sort of that third area. And this is a part of the area where MCP can be very helpful, because that MCP protocol, you can program in the ability for it to go access the context and semantics that it needs wherever you store them to get better results. Okay? So again, just kind of thinking, okay, I got these three problems. What are potential solutions? Again, we're going to be focusing on the data integration piece, access to data. But why would Iceberg solve the access to data piece? Well, the reason is because the idea is you're solving the problems that a lakehouse is trying to solve. To understand the problems that a lakehouse is trying to solve, we need to understand what came before lakehouses. Okay, traditionally, and still to this day, what do we love? We love databases and data warehouses because they do a lot of cool things for us. Okay, when I use a database or a data warehouse, I don't have to think about how the data is stored. I don't have to think about how does it know which data is part of which table? How does it know how many different tables exist, a catalog? When I write a SQL query, how does it know to take that SQL query, turn it into an abstract syntax tree, turn that into an execution plan, and then go and execute that plan, maybe after optimizing that plan for a little bit? I don't know. Okay, it just does it. It's all abstracted away in a nice vertically integrated system that I can just use to work with my data. Whether I'm talking about row-based data in a transactional system or columnar-based data in a analytical system. So that's all well and good, but what's the catch? The catch is that every system does it differently, okay? How Postgres stores and handles all these different things is gonna be different than the way SQL Server does it, or different than how Redshift does it, different than how Snowflake does it. So what does this mean? Whenever I put data in any of these systems, my other systems can't talk to it. And this creates this whole problem, okay? Where you see something like this, where you might have, especially when you start getting to much larger enterprises where, in order to be nimble, each department might be building its own data platform. So sales might have a separate data platform than finance, which might have a separate data platform than marketing, but they've all decided to standardize on different things. So maybe sales is using AWS, finance is using Azure, marketing is using Google, and now every time one department wants to use data from another department, they find themselves doing this ETL cross clouds, with all the costs that kind of come with it, okay? And that's not ideal, okay? So the goal is, and the problem is when you try to standardize and say, hey, how about we all use the same tool? Everyone's gonna be like, well, we like our tool for X and X reason, for X and X and Y feature, and you end up having all this politics play out, okay? Which tool is gonna be the tool that wins? How about we don't fight over what tool you use? How about we just agree that the data will be in the same format that all the tools can talk to? Okay, and that's where Iceberg comes in, okay? Instead of me having to juggle a bunch of all the credentials for all my tools, I can just say, hey, I'm going to access, for my agentic AI, I'm going to access Iceberg data. That Iceberg data, I can use a single, or whatever particular engine I want to use, and I can have a larger swath of my data, because while everyone's using different tools, we've standardized the data format, okay? And you basically get into a world of basically using your data lake as your data warehouse. So basically, before, where we had data lakes that had like Parquet files, images, and text, which we still do, the problem was the Parquet files were just looked at as files. Our tools would just be like, hey, you got these Parquet files, and maybe you could kind of treat it like a table, sort of, because you could tell it, like, hey, this folder is a table. But with a data lake house, we take what we had before with the data lake, where we had a storage layer, and we had tools that could run some analytics, tools like Dremio, AWS Athena, that could run queries against your data lake. But we realized there's some pieces missing. So with a data lake house, we just add the pieces that are missing, which was a table format, like Apache Iceberg, catalogs, like Apache Polaris, and others. And now you have a system that really does kind of work like a data warehouse. But again, the actual storage piece, all the tools can access. So again, you get rid of the politics, you get rid of the excessive ETL between departments, because everyone's tools don't talk to each other. Because they don't need to talk to each other, they just need to be able to talk to the data. Okay, and you end up in a world like this, where life becomes a lot simpler, because you just take your data sources, you ingest them into your lakehouse, which just means you're gonna write a bunch of Parquet files, and on top of those Parquet files, a bunch of metadata files are gonna get written describing how that's a table. And then that table, that metadata, is gonna be referenced in a catalog saying, hey, this table belongs to this metadata. And now every tool, whether it's Dremio, Snowflake, Flink, Spark, Upsolver, which has been acquired by Click, I gotta update the slide, can talk to the data, okay? Basically every tool, every table you visited today while you're in the lobby, those are all tools that can talk to Iceberg, to think Iceberg. And that's the beauty of it, okay? Everyone gets to work together when it's Iceberg. And you end up in a world like this, where now, again, all the departments, they just ETL the data into the lakehouse, and they can grab the data they need from the lakehouse without necessarily all the friction you had before. So that solves a lot of the data access problem for agentic AI. Not all of it. Okay, as I'll mention again later, there's this whole other world of data you don't have access to or don't have control over, like data you've purchased from third-party providers or data you're sharing with partners and stuff like that. I'll discuss a solution for that as well. Okay? And again, we've kind of already established what Apache, I think at this point everyone knows what Apache Iceberg is, right? If you're here. Okay, oh, Thursday. Wait, no, it's not even Thursday, it's Wednesday. Oh, Wednesday. Okay, I'll explain what that joke is about. Basically, when I do public speaking, every once in a while, you try to be funny and no one laughs, okay? You guys know where I'm going. Okay, so what I can do is I just say the day of the week. So in this case, Wednesday. I'll just say, oh, Wednesday. It doesn't matter what the day of the week is, because we've all had a bad Wednesday. We've all had a bad Tuesday. We've all had a bad Thursday. So when I say that, everyone's just like, yeah, I know how you feel, Alex, and Jenny will laugh along. Maybe not this time, but but the idea is that it just helps keeps the presentation moving along. So nice tip, if you're ever doing public speaking and you just need to cut the tension, just say the day of the week, Wednesday. Okay, cool. But again, we know what Apache Iceberg is. You've probably seen this chart in several presentations today. Okay, so I'm not going to belabor the point. You get it. It's basically 3 tiers of metadata that are being tracked as files that describe the list of files that are part of the table. That's the beauty of it. Okay. But again, all your tables have to be tracked by a catalog, okay? And this is sort of like the big question we have right now, or one of the bigger things in the data lakehouse space that's being explored, this whole world of catalogs. Now, luckily, there's this thing called the Apache Iceberg REST catalog spec that makes it where you can pretty much use any tool to talk to any catalog for Iceberg, okay? And that's great. But it still will, like this whole catalog conversation will matter over the long run still, because at the end of the day, not everything it will be Iceberg, right? You'll still have unstructured data, other types of data. So generally, whatever catalogs become the dominant catalogs will be the ones who get to determine what the APIs are beyond Iceberg. Okay, what are going to be the APIs for unstructured data? What are the APIs going to be for other table formats or other different types of tables? Okay, so basically, again, very, very interesting space to be watching the catalog space to see how that evolves, which catalogs end up becoming dominant. Apache Polaris is one open source project that already is being adopted by several different vendors. But basically, it's an implementation of the Iceberg REST catalog. So that means, like any catalog that's an implementation of the Iceberg REST catalog, all tools can talk to it. Any tool can talk to this catalog to read and write Iceberg tables, okay, across any cloud. And actually, with the most recent release, you can even use S3 compatible storage, okay? So good stuff. But one of the interesting things about Apache Polaris is that you have several different levels of isolation of your data. So it's not just a catalog when you deploy Polaris. You have the ability to create multiple catalogs. And under any of those catalogs, you can create multiple namespaces, aka folders, and then you can create tables underneath. So you can organize your data and govern that data pretty fine-grained. And you also have RBAC. And the way RBAC generally works in Polaris is that you have principals, aka users or services, and you have your catalogs. So essentially the way it works, you have two sort of layers in between. So you're going to say, hey, principals have principal roles. They say, hey, what kind of principal they are, analyst, engineer, shipping partner, whatnot. And then you're going to have catalog roles that determine sort of the level of access to that particular catalog and its tables. And this allows you to kind of create your own taxonomy for how you want to govern your data. So now going forward, the initial setup to create all these catalog roles can be a little bit, but once you have it, it becomes really easy. I can just say, hey, you know what? The analyst should be able to read data. So they're going to have access to all the reader roles for all the catalogs. Okay, the engineer, well, they need to read, the data engineer, they need to read and write, so I'm going to give them both roles for each of the catalogs. And our shipping partner, well, they just really need access to our logistics data, so we're just going to give them the reader role for the logistics catalog. Okay, so I can do some fun governance like that with Polaris RBAC. But the end story is you end up with a world that looks like this. You start standardizing more and more of your data as Iceberg tables. Now, those Iceberg tables are going to sit in a catalog. Oh, wrong button. See, now, here's the thing. When you buy clickers, like this is the clicker that I brought, the best thing to do is to do the ones that have the arrows right and left. Because when they're up and down, I end up hitting the back button more often than not. Okay. But you have your Iceberg tables, and in Polaris, those Iceberg tables can be tracked by Polaris, which is called an internal catalog. And you can have them in other catalogs, because you might have an AWS Glue catalog that has some tables, because you're doing some work in ingestion work using AWS Glue Studio, okay? You might be doing some work in Databricks and have a Unity catalog, and you want to basically federate all those catalogs so you can see all your Iceberg tables in one place, okay? So this, again, helps unify your data so you're not having to put so many different credentials in your agentic AI code, okay? So now Polaris is not only providing you federation of your catalogs, but also that governance, that RBAC. You're getting all that layer there, so that way, you're basically giving your AI agent, and the other thing I didn't even mention in the slides, let me mention that now. Another really cool thing about the REST spec is you have this feature called credential vending. So in that case, you don't even need to put the storage credentials in your code. All you have to do is give it the catalog credentials, and then it can execute sort of the transactions and get the storage credentials as needed, okay? Providing another level of security, which is very nice. Okay, wrong button again. Okay, cool. Now, what's going to happen is eventually you're going to need to access and do queries on those tables, and that's where you need some sort of lakehouse engine. These could be, that generally has some sort of federation features. Could be a Dremio, there's options, but the hat. But ideally, whatever choice you make, it should be leveraging Apache Arrow to get that fast processing. Because again, it's not just about having access to all your data, it's about performing access to that data, okay? And then some sort of semantic layer, where the semantic layer is built into the engine, or the semantic layer is some sort of external facing tool, okay? So that way you have access to semantic data that explains how your data actually works, okay? And what columns that things should be joined on, and what's the purpose of this particular data set. Okay? Now, then what happens is you have MCP servers, and those MCP servers then interface with your lakehouse engine and your semantic layer to be able to pull that context from the semantic layer, to be able to run those queries against your data lakehouse to then be able to kind of satisfy those prompts. Okay? And now, this becomes a lot simpler. Okay? Your MCP server is now really just kind of connecting to one thing, has access to all your data. And again, if that lakehouse engine has federation features, it can connect to your other databases and data warehouses to bring all that data into one place. And it just becomes a lot. And then if you have that semantic layer, you're going to get better responses more of the time. Okay, but again, Iceberg's role in all of this is kind of bringing all that data together to create that sort of fabric where you have access to more of your data sooner than later for these kind of agentic projects. Okay, and of course, all these problems get additional solutions when you use tools like Dremio, like us over here. Okay, when it comes to the data access problem, again, we provide federation, which includes an embedded Apache Polaris-based catalog, so you get the catalog out of the box. and you have the ability to connect to pretty much all your data sources across clouds. We process everything in Arrow, so you get the performance, and we have a built-in semantic layer, and MCP server that leverages that semantic layer. So whether you create your own solution that kind of fits that design that I've talked about throughout this, or you have this, it's all good. But with that, again, I want to remind you guys that you can get free books by scanning this QR code. So if you haven't scanned this QR code yet, please do. Okay. So you can get the free books. Okay, and okay, that's the end of the slide. So I can probably have room for like 1 or 2 questions. So anyone got a quick question for me? Hopes, fears, dreams? Yes, Tej.
Can you talk a little bit more about the semantic layer? What problems is solving? How do you?
Yes, okay. So question is to talk more about the semantic layer, how it solves problems. So bottom line is where the semantic layer comes in is this. It can come up in a lot of different types of information. So this could be like your data lineage. How do your tables relate? Column names, other like primary keys and foreign keys to help understand how different tables should join each other. So now different semantic layers kind of come up in different forms. Like this is a big conversation right now. Like right, so Snowflake made an announcement earlier this week about its semantic initiatives, and AtScale is doing a thing. Dremio, we're making a lot of investments in our semantic layer. So the idea is just trying to create information that helps the AI understand your table. Again, with us, again, you have the data lineage, but you also have a built-in views, and the views can oftentimes have more semantic column names, and then through a built-in wiki, they'll help put in a lot of that other data.
Oh, my question is, like, how and when is this semantic layer like stored and computed? Like, is it like cached in memory, or is it like during query runtime? It's
going to depend on what tools you use to decide the semantic layer, but essentially the end result should be for example, this is a Python library that just got released recently called like boring semantic layer that I think just kind of creates a bunch of markdown files. But bottom line, wherever that semantic information is, what you would want is that your MCP server knows where it is, grabs it, and then would put it into the prompt alongside your actual data, so that way it understands all your data schemas. So we take a look at the schemas of your different tables along with the semantic context and be able to better understand how it's going to use those tables. But where it's stored will depend on the platforms you use. Do I have time for that last one, or should I? Okay, go for it. Let's do it.
How important do you think natural language queries are, like from your perspective?
It depends on the use case. There's going to be a lot of times where just writing the SQL yourself is probably going to be much more efficient and much more productive a lot of times. But there's going to be also a lot of times where you're trying to create accessibility to people who don't know SQL to democratize access to the data. And that's where I think, especially like the design that we're talking about in this presentation really comes alive. Okay, because I mean we see it in Dremio, where basically we have people using Dremio's MCP server, and literally we're asking natural language questions about our data and getting really good answers. And that allows a lot more people in the company to have a lot more ability to speak up in a quantified way about decisions within the company. And I imagine a lot of companies would benefit from that, versus, now of course, you have to make sure you take the steps to validate it, provide the semantics and all that stuff. But for providing more business users better access and better answers quicker, for more nimbleness, I think that's very useful. Now for certain jobs where basically, hey, people who probably know SQL and probably can write a better SQL statement than can be and almost just as fast as it can be generated, maybe not the right use case. But to me, it's about making it accessible to people who didn't have these powers accessible to them before, more so than speeding up the ability for people who could do it before they keep doing it. Or at least that's the way I generally think about it. Okay, I think I'm out of time, but I will. Let's talk as soon as this. Well, you're coming up right after me. You're the next speaker. Yeah. Okay, so he's the next presenter, so he's gonna elaborate even further on the question that I just gave. So if you guys want to hear that, make sure you stick around for the next presentation at 4:30. But with that, I am done. My name is Alex Merced, head of DevRel at Dremio. Thank you very much. Stick around for the next talk. Woo!